Hey everyone, speaking with us today is Dr. Shruti Rijhwani, research scientist at Google, who is currently using natural language processing to revitalize endangered languages. Her groundbreaking research has also led her to be featured on the Forbes Dirty Under Dirty list. Dr. Rijhwani, would you like to tell us a bit more about your background and research?
Yes, sure. I would be happy to. Thank you so much for having me. Yeah, so I'm going to tell you a little bit about the research I did in my PhD. I'm going to be just going to present a few slides to demonstrate what I did, and of course, after the talk, we can discuss and we can have some questions as well. Um, so I guess the broad question that I tried to work on during my PhD research. So all the work I'm presenting today was done when I was a PhD student at Carnegie Mellon, although I am a research scientist at Google, and I have been for the last couple of months after I graduated. So the main question that I was trying to answer is 1,500 languages of the world are expected to disappear within this century. And can artificial intelligence technologies help preserve and revitalize them? So I'm going to be focusing on a category of languages known as endangered languages, and these are languages that are at risk of falling out of use, primarily because the number of native speakers is rapidly reducing, and younger speakers have limited or no knowledge of the language. So 40% of the world's 7,000 languages are actually endangered. So these 40% languages are at risk of disappearing completely, and 1,500 of these are at risk of disappearing within the current century. So the field of artificial intelligence that I was doing research in is called natural language processing. And natural language processing, or NLP, focuses on building AI tools for understanding human language. And NLP tools are actually very common in the world today. A large percentage of the world's population uses these tools on a daily basis. For example, a lot of us use search engines like Google. On our phones, we have predictive keyboards that tell us, quickly what we might type next, and we can just use that instead of typing the words. We use things like Google Translate to translate across languages and understand text from other languages, as well as home assistants like Alexa, Siri, or Google Assistant. So all of these tools, products, and websites are based on NLP, or natural language processing, and because they help us understand human language. And what I wanted to do during my PhD is, can we build similar technology that can understand endangered languages and potentially help preserve these languages for the future? Building NLP for endangered languages could have many benefits. Because these languages are in danger of dying out in the next few decades or centuries, there exist many programs to preserve, document, and revitalize these languages. And essentially what that means is preservation and documentation of the language involve collecting as much information about the language from native speakers before the language disappears completely. And this is in order to preserve the history and culture of that community. Additionally, revitalization of these languages involves encouraging younger speakers to learn the language, to use it in their day-to-day communication, to use it both at home and outside of home, and so on. So this is in order to revitalize the language, get more people to speak it, and hopefully prevent the language from disappearing. So we could build NLP technologies to support these types of programs, make it easier for people to preserve and document languages, as well as make it easier for people to learn endangered languages. So how can NLP help here? We could use NLP to build adaptive language learning tools, similar to Duolingo, which has many languages, and it uses NLP and other language technologies to understand what exercises and questions to present to the user next. And it would be it'd be very useful for teachers and learners of endangered languages to have something like this for their own language. Being able to translate from an endangered language to another language can make it easier for people to understand, as well as, you know, the other way around, to learn the language, as well as having predictive keyboards for speakers to easily be able to use this language while typing, texting, searching, using the internet, and so on. Additionally, many researchers, linguists, speakers, and teachers of endangered languages would like technology like automatic speech understanding. These technologies work pretty well for English, like you might have seen Alexa or Google Assistant, where you can ask it questions like what the weather is and so on. And being able to do the same thing for languages, for endangered languages, would encourage people to speak these languages more. And we could also do something like optical character recognition, where we convert old documents that are maybe scanned or just in the print format, convert them to formats that are digital, and then people could access them from anywhere in the world and be able to access all of this knowledge that is currently only in this endangered languages. So my research actually focused on improving technologies for this specific application, optical character recognition. And I'll tell you a little bit more about it in the next slide. So optical character recognition, or OCR, involves converting print books, handwritten notes, or typewritten books, which currently only exist in physical paper form, to a machine-readable format. So being able to take these books, scan them into images, and then extract the text out of those images so that people can use the text similar to how you would just use typed text. So there are lots of scanned books like this in endangered languages. So the Internet Archive, which is a public archive that anyone can access, has around 11,000 scanned books in endangered languages. And there are also over 20,000 documents with other information about endangered languages, including linguistic notes and other archival materials. And because all of these documents are only in the form of scanned images, the text in them is not machine readable. So you can imagine that this actually, it causes lots of inconveniences for people who want to read and access these documents. When the text is not machine readable, you can't search through it. So if you need to find specific information, you have to look through hundreds or even thousands of images just to find the specific text that you're looking for. And additionally, the text cannot be shared. They can't be directly translated using automatic translation systems. And it's just very difficult to access them either on the web or on mobile. So there are lots of advantages to converting this text from a scanned image to a machine-readable format, and that's what we're going to do today. That's what I'm going to talk about today. And OCR systems actually exist for many languages. For example, many apps exist that can do OCR on English documents, for example, really well. So you can just take a picture with your phone and of any printed document, like a receipt or a bill or a letter or something like that. It'll automatically extract the text for you, and you can save it. It works well even on handwriting. And then you can search through that text after OCR is done. But unfortunately, a lot of the existing tools don't work very well for endangered languages. And that's what my research was trying to improve. So to improve OCR for endangered languages, my work, along with my collaborators, we essentially developed new NLP techniques that improve the accuracy over existing OCR systems by up to 59%. So I'm just going to show a quick example of some of the improvements that we did and what difference it actually made to people who read these books in endangered languages. So this is just a random example from a 100-year-old typewritten document in the endangered language Kwapala. It's a language that's spoken on the western coast of Canada. And this document actually has several thousands of pages, and they're all in the same format. They're very old. They've never been converted into a machine-readable format. And researchers value these documents a lot because they have a lot of information about the culture and the traditions of the Kwakwala community. But so far, what they've been doing in order to get the information is just looking through several hundreds of pages just to find the information that they need because the text is not machine readable. So if we applied some of the existing OCR tools that you can freely use on the internet, you actually get an output that looks reasonable, but it has quite a few errors. So I've highlighted all of the words that have at least one character that's incorrect, and you can see that most of the words actually have at least one character incorrect from the outputs from existing OCR tools. So with the new techniques that I developed during my PhD, we were able to correct most of the incorrect words and make the document very close to what the text very close to what the original document had presented. So you can see there are some words that still remain incorrect, which are still highlighted in red, but all of the words highlighted in blue were corrected by the NLP method that I developed. So as you can see, it really improves the readability of the text. People will be able to search through it, be able to access it more easily now that we have an improved OCR technique for this endangered language. So that was, of course, just a single example that I showed you, but the software that I developed has actually been used on a whole bunch of endangered languages and around the world by researchers around the world. Our software has been used to convert thousands of pages of scanned documents to high accuracy machine readable text. And we also got some nice feedback from people who've used it. So someone told us that our software was completely transformative for the poor quality text they have, and imagine that a lot of people would want to try it on their own documents. Our OCR system was immensely useful as some researchers collected documents for the Quechua language and also made Tibetan documents easier to proofread for researchers.
About your work, what were some challenges you faced when creating the models for underrepresented languages?
Yeah, that's a good question. So I'm gonna make my answer, I'm gonna just give some background. Natural language processing and NLP technologies use a technique called machine learning to build models or systems or tools. And in machine learning, one of the most important things is, so machine learning essentially looks at existing data and then tries to make predictions on new data. And machine learning systems tend to work better, as expected, if you have more data to look at in the beginning, so you can make better predictions on data that you see in the future. So when we're talking about, underrepresented languages or endangered languages, one of the biggest challenges is, in fact, getting data that's clean and usable for machine learning models to learn from. So I think that was one of the biggest initial challenges, is just trying to figure out how we could build systems and use machine learning to work with very little data, and how we could even obtain that very little data, and how we could use it in the best way, try to change our models, change our systems to use the little data we had in the best way.
Finally, for our last question, this is more general. So,
Okay.
How can high schoolers get involved with natural language processing?
That's a good question. I think that as I said, I didn't work on natural language processing research until after I graduated from college. But I think that especially now, because it's especially now, if people are interested in doing it earlier than that, and that's a great thing. I think that there are a couple of ways to go about it. In terms of being at high school, it would be good to take classes that are focused on programming or learning computer science or some fundamentals of computer science. Potentially classes that have some component of artificial intelligence or machine learning, just to kind of just to kind of learn the basics. Of course, there are lots and lots of online courses as well in order to learn the basics. But when you're in high school, if you have someone who can teach you in class, or if you have like a club or a group or something with friends, that's of course a lot easier and more fun to learn from. So I think that would be a nice way to start. And in terms of NLP specifically, I think that after graduating from high school and going to college, a lot of schools do have machine learning and NLP classes, sometimes at the advanced level. So I'd recommend people to maybe go to take those classes or work on projects in those classes. I think especially in terms of doing research itself, I think the first step is figuring out if you're interested in NLP or some other area of machine learning, or even within NLP, is there a specific thing that you want to work on? I know it's not the easiest thing to like go and read scientific papers and so on. I certainly found it very difficult when I first started with research, but especially now there are lots of less technical blogs and things like that to learn more about what's happening in the field. So I think that would be like a good place to start, just to see what's going on, whether you're interested, what part of it you might be interested in. And then I think the next thing is, especially if you're in college, after high school, many colleges have computer science departments where there are professors who do machine learning and NLP research, and potentially working with them or working with their students on projects would be a good place to start. Additionally, there are lots of open source technologies for NLP that people can learn just on their own. So that's something I ended up doing, especially in the early years of my PhD. I just sort of explored what the different open source frameworks are, what are easy to learn, what are easy to use, and just started from there. So I think that was a pretty generic answer of how to start. Of course, it really depends on what you're specifically interested in. But as I said in my slides, I'm very open to having these conversations. So if anyone is actually interested, just feel free to email me, and if you have some ideas, and I'd be happy to give pointers on how to get started.
All right, thanks for that advice. Well, everyone, thank you so much for watching our interview with Dr. Shruti Rijhwani. Take care, and we'll see you all next time.